Now I have my 3 samples. Hold on. I'll say samples for data assignment 3. Just gonna put it in a nice folder over here. Okay, so what are we doing with these 3 samples? So first of all, upload sample 1 in StatCrunch, then answer questions 1 through 3. Oh, if you can change this to 4 for me, that will be great. I think I added an extra question this semester. That's why that wasn't right. So if you can change that to 1 through 4, that will be great. I should change it. Okay, it says, number 1, construct a 95% confidence interval for the mean height for all students. Then select T-stat, 1 sample with data. Well, this is nice. I'm giving you exactly how to create this 95% confidence interval. And it says column should be height and the confidence interval option should be chosen. Provide the output table. All right, let's do this then. So you will go to StatCrunch, statcrunch.com, or go from my lab if it's working. I had the worst week. It wasn't working like for 2 days in a row. Okay, so I'm in here. I'm going to import my sample of size 25. So you will click on data, load, from file, from my computer. That's where I'm going. Click. And I can, remember I have a folder, right? I have a folder with all these samples. I will drag, where'd that go? I will drag the sample of size 25 in here. I'll go ahead and click on upload. Now it's here. Yay! And just double checking. Yes, I have 1 through 25, so it's perfect. I'm going to construct a confidence interval. Go to stat, T-stat, 1 sample with data. And number 2 will ask us, why are you using T-stat instead of Z-stat? And we'll answer that. Click on with data, and we want to create a confidence interval for height. So you're going to click on height, go down, and change it to confidence interval for mu. And let's see, did they want 95%? Let's just double check. 95%, so that's right, 95%. And I'm done. I'm just gonna have to scroll all the way down. I don't think I can change colors. Who knows, maybe. I don't think there's any colors, but I will come down and click on compute. Yay, we got it. I'm gonna just take a screenshot of this. And then put it on number 1. We are done with number 1. So I don't even know what it says right now, so we should talk about the result in number 3, 4, and I think 3 and 4. But that's what you do for the first question. Okay, now let's see. Number 2 is asking, explain why we create. By the way, guys, I have to tell you this. If someone submit a same exact confidence interval, I know then you're using my picture. Don't use my picture, okay? You and I will have a different lower limit and the upper limit. You know, all these numbers will be slightly different, or maybe the difference is a little bit bigger. You and I downloaded separate random samples, so no one will have the same output table. If someone has the exact same output table, I will have to ask you to try to do it again, okay? It says, explain why we create T interval instead of Z interval. I'll show you why. If you go to Z-stat, 1 sample with data, what are they asking you over here? Standard deviation. Now remember from class, I'm sorry, I'm stuffy. I'm so stuffy. The allergy. I'm going to open up 6.3 slides real quick. Oh, I'm sorry, 6.2 slides real quick. And around right here. When population standard deviation is unknown, we're going to use t-distribution. That's why. We did not have population standard deviation, which means we didn't know the standard deviation for heights for all students. So we have to use the t-interval. We have to create t-interval instead of z-interval because the population standard deviation is unknown. That will be the reason. That's why we have to use t-interval instead of z-interval. What kind of fun fonts do I have? Ooh, I'll use that one. Okay. So we're good with number 2. Let's keep going. So we must, okay. What is the margin of error for your confidence interval? Now, we can do it the longer way by figuring out the critical t-value, multiplying it by the standard error and all. But I'm gonna just go ahead and use what I found above here, okay? I wonder if I have equation type here. Symbol? I don't think I have equation math editor. That would be a nice tool to have. Let me see. I mean, I think I'm just gonna record this too. No add-ins. If I can go install math. Office store not available. Oh, what? Okay. So I can't use math type. So I'll just go ahead and type it. So margin of error. Margin of error equals upper limit minus point estimate. Well, in this case, the point estimate is the sample mean. I have all the numbers that I need. Upper limit from this table is 161.24093. Sample mean is 156.92. So if I type this into my scientific calculator, I'll show you. I'll just do it on my iPad computer calculator. 161.24039 minus 156.92. That equals 4.32093. So that's what you can do. You don't really have to do it the longer way unless you really want to. Should we do it just for the fun of it? Yeah, why not? Margin of error, the other way around. But you do not have to do this. So if you want to just skip forward a couple minutes, that's okay. But it is critical t-value times sample standard deviation divided by square root of n. Oh, I wish I can write math type, but I don't have math type in this. Oh, okay. Well, okay. So let's find the critical t-value. Critical t-value equals, I need to read it from the t calculator. So I will go to StatCrunch. I will go to stat calculator t, and I'll tell them that the degrees of freedom is 24 because the sample size was 25. Degrees of freedom is always one less than the sample size. I want the critical t-value. So what I will do is I will enter, hey, you know what? How about I use a between calculator? That's better because what I can do is I can tell them that I want 95% in the middle. Degrees of freedom is 24 because my sample size was 25 and 1 less than 25 is 24. and I put 95 in the middle because I want it to be a 95% confidence interval. If I hit compute, the critical t-value is 2.0636. Okay, so on my Word doc, I write that critical t-value is 2.0639. What is the sample standard deviation? I have to find it, right? So I can go back to my StatCrunch and find the sample standard deviation. Go to Stat, Summary Stat, Columns, and I want to find the standard deviation for the height. That's all I want. And that comes out to be this number. And this number, when you do it on your computer, is going to be different from what I have because my sample and your sample are different. You agree, right? So my standard deviation, the sample standard deviation is, I don't want them to edit my 10.467887. Now lastly, I need the sample size, n equals 25. So I have everything I need to find the margin of error by hand. How about I use Desmos scientific calculator to do that? And by the way, guys, what I'm doing right here is completely unnecessary if you want to just do it by this method, okay? So if you're still watching, you're just doing it so that you can, so that you have another method of doing this, okay? So I'll go ahead and type this formula in here. Look at this for me. I'll do critical t-value 2.0639 times fraction, which has the sample standard deviation of 10.467887, and that's getting divided by square root of 25 in the denominator. So as you can see, I'll go ahead and include everything. As you can see, the standard deviation came out to be, I'm sorry, not the standard deviation, margin of error came out to be 4.320934396. So let's compare this to what I got above. Are they the same? 4.32093? Yeah, they're the same. So up to you which method you use, but you obviously see the easy method and the slightly more complicated method. So if I were you, I'm just going to stick with this. Margin of error is the distance between the upper limit and the point estimate. Or you can do it differently. You can do lower limit. You can find the distance between your lower limit and the point estimate, the sample mean, which will be the same. So that's probably enough for number 3. All right. Let me just do another page. Okay. Guys, hold on. Ooh. Sorry, I'm just playing with this now. I think I broke it. Okay, anyways, let's keep going. Sorry about that. Number 4 now. Number 4. Write a standard sentence for interpreting a confidence interval to summarize your result. Okay, we can do that. I'm just gonna, I need these numbers. I need these numbers. I can say with 95% confidence, I can say that the population mean height for all students is between 152, let's just round this, okay? 0.6 centimeters and 161.2 centimeters. Upper limit and the lower limit. So did I answer it? Yeah, we're done. We gave the lower limit and the upper limit, so we can say with 95% confidence the population mean for all students is in between this number and the other number. Of course, your numbers are going to be different, but based on my output table, that is my answer. So I'm done with number 1 through 4 in this video. I will stop recording and we'll come back and do 5 through probably have to cut it a little bit shorter. 5 through maybe 13 in another video, okay?